Why don't you go ahead and tell us what your talk is about? Give us a summary.
When I first learned C++, I didn't know anything about inheritance or object-oriented programming or anything. I knew literally nothing about it. What I did was I picked up Bjarne's book on C++ and I read it. And there were things like member functions, and I'd look at the member function, and the member function has an implicit this reference. But I didn't know that. And I was going, how the heck is this function manipulating the contents of the struct when it doesn't have a reference to it? And then virtual functions. I was completely baffled by virtual functions. What do they mean, virtual functions? What do they mean, overriding functions? The book kind of went over it and explained it and showed examples, and I had no idea what was happening. So at the time, there was the C-front translator that Bjarne Stroustrup had written, which translated C++ into C. So I had access to that, and I just fed the program examples into C-front and looked at the C code coming out. And then I saw the hidden parameter. I saw that the virtual functions was just pointing to a table of functions and function pointers and picking a function pointer out of that and calling it. And then all of a sudden, the whole thing made sense to me, what was happening and how it worked and all that. That's always been true for me. I've never been able to understand things from descriptions of the top level behavior. I needed to understand how it was implemented underneath in order to figure out what was happening. And I've noticed that, some members of the D community have the same thing. No matter how well it's described what the behavior is, they're not seeing how it's implemented under the hood. And this impairs understanding of how things like the function and parameter attributes work. Constantly, people have trouble with how things like scope and return and ref work together with function parameters for member functions and things like that. And it's not making sense to them. And I always encourage them to rewrite it in terms of just simply pointers and values, and then how the attributes are applied will make a lot more sense. So I'd keep going, here's how you rewrite it into pointers and values to understand it. And I finally realized I just need to make a talk on the internal rewrites the compiler does to reduce all the syntax sugar in D into simple constructs like pointers and values, which people coming from a C perspective understand. So that's the point of this talk. It's just what is happening with those higher level constructs in D and how do they work?
I was aware of most of that. I was actually surprised by one of the items in there, and I'll get to that later since these guys haven't seen it yet. Ricky suggests here, now if only foo array equals constant could be a for each rewrite instead of a call into the runtime.
I can explain the difference on that. The difference is the for each loop is rewritten into ifs and go-tos. And the intermediate code of the DMD compiler can only handle expressions, not control flow. So by rewriting it into a function call, then you can have it, these array assignments embedded inside expressions. Whereas if you turned it into a for each loop, it wouldn't work because of the way the AST works in the DMD compiler. So that's the
Ricky's
explanation for that.
Yeah, Ricky's motivation is that because it doesn't work in better C, the array initialization like that.
It should work in better C.
Well, if it's calling into the runtime and the runtime's not there.
Yeah, but it calls a template. See, if you call a template, you don't need to link to the D runtime library because it gets expanded into your...
Ricky says it's not a template.
It's not?
It's in RT package, runtime package.
Well, I'll have to look into that then, because I thought that Razvan had changed it so it called a template.
Well, I know Theodore is working on the runtime hooks. I guess he hasn't converted that one yet. Is that the case, Ricky? Is that what you're talking about? There's a list of stuff that Teo has converted so far.
Okay, I thought all the array operations had been converted to calling templates in the
No, it's in progress. Apparently, it's a lot more work than.
Okay.
Okay, but he says there's an issue for it, and it's not on anybody's radar. All right, your talk has started, and now I can ask about something I've been wanting to ask about, but didn't want to say anything before the talk started. What's up with the hats? That was a cool idea. I like that.
Hat?
Yeah. Where did you get the idea for the hats? Where did that come from?
Well, Seattle used to run a sketch comedy show, and it was in the 90s, and they were rerunning it. So I decided to record it for nostalgia reasons. And since I was watching multiple shows at one time, I noticed that the host never wore the same shirt twice. It was always a loud shirt with a dramatically different pattern. And as far as I can tell, over 50 episodes, he never wore the same shirt twice.
Wow.
So I was thinking, well, I should do that. I should just start, switching my shirts through the talk. And then I thought, well, I've got all these various hats. I wonder how many hats I actually have. And so basically, I never throw anything away. And I wound up with this big pile of hats and thought I could make use of them. So
that was my
anyhow.
That was my next.
My talk is for the less experienced deprogrammer, and for the more experienced ones, I thought I'd try not to be totally boring.
Yeah, I totally love that that you did that. That was a surprise. I was watching, and then I saw the hats change. I was like, what just happened? I just wasn't expecting it. I wasn't expecting the first hat either. But my next question was, okay, you say you wound up with a pile of hats, so that implies that you're not collecting them intentionally, or are you collecting them?
No, I'm not collecting them. It's just the fedora was a gift they handed out to all the groomsmen in a wedding I attended. So I wound up with a fedora, even though I've never worn it. And, the helmet is for when I went on the racetrack one day and I had to have a helmet. And my D-man hat and my 757 hat, you just kind of wind up accumulating those things over time.
No, I was curious because I know we did have a member of the D community years ago, the guy that did DSSS. You remember the package manager and build tool, Gregor, I think his name was. Yeah.
Time ago.
Yeah, he always had hats on. I believe he was a collector, and I have a friend.
Oh, yeah.
Yeah, I have a friend in Iceland who collects hats, and he's always asking for them. But anyway, I just thought that might be something you did. I was looking at the compiler spelunking features that you listed on here. And I think there are some, unless I'm mistaken, a couple of those command line options don't show up in the help list.
I put in a PR to document them, and some people objected to it. So that PR went nowhere. I tried.
Yes, because I these are all new to me. I wish this --b.
It used to be for my own debugging purposes only, and the compiler long ago was written for a 16-bit machine, so every byte I could squeeze out of the release version of the compiler was a win. So all that debugging code and all that was only there for debug builds, and I got so used to that I'd forgotten that memory became a lot more available. And eventually I realized that these debugging switches should always be available. So I just enabled them in the release build. And then I finally thought, I need to document these because they're so darn useful. So I tried to document them.
Well, we should probably document them on the website, at least. The talk hasn't got to this part yet, but you said something in there that I didn't know, and that was, I may have heard this a long time ago and forgotten about it, was that the while loop is rewritten to foreach, or for.
It's rewritten to for loop.
For loop, yeah. And you said that was Andre's idea. He convinced you to do it. Tell me that story.
Oh, well, originally the while loop had its own semantic routines, and all the way going back to the code generator. And I'm talking to Andre, and Andre says, what you really ought to be doing is not defining the while loop with all this stuff, but you define it as a rewrite into a for loop. Because then no errors can creep in when you have duplicated semantics and different implementations. They wind up, naturally diverging as maintenance is done on it. if you define it in terms that can be expressed as a for loop, all you got to do is then rewrite as a for loop, and then you can delete all that other code you had that implemented the while loop. Then you only had to worry in the compiler about getting the for loop right. Because if you got the for loop right, then everything that rewrites into a for loop is going to be right.
Mm.
So it simplifies the compiler and it reduces the chance of creeping bugs getting in where the while loop actually behaves in some tricky way different from a for loop.
Mm-hmm.
You don't want those kind of things tend to happen when each construct is defined on its own. So by getting constructs defined in terms of each other is a large language simplification issue, both for the user and for the internals of the compiler.
Well, I guess this was not a new concept for you. I mean, D was already doing some lowering before in other features. Yeah. So were you looking at features independently as self-contained blocks?
Yes, I was doing much of that, and Andre just kind of, you're right. I was thinking, why didn't I think of this before?
Mm-hmm. No, I was just wondering if it was a paradigm shift for you. Yeah.
It was a paradigm shift for me. And it sounds so stupid that I didn't think of it before, but I didn't.
Well, it seems like an interesting way to build a language. You define your fundamental building blocks and then add your features, expand your features on top of those.
Yeah, it's a great way to manage complexity. It's like over time, the code base itself develops a lot of redundancy in it. And I put in a refactoring pull request just a few days ago where there was a virtual function in the implementation, and that was part of the early implementation of the compiler. And later on, I had added a higher level construct, but I'd never gone back and replaced that virtual function call with using the higher level construct. And when I was looking at the module info implementation, I noticed that that was the only use of that virtual function was in implementing the module info generation. And if I rewrote it in terms of the higher level construct I had, I could actually simplify the compiler by getting rid of a virtual function. There's kind of an ongoing technical debt issue that accumulates, and every once in a while you want to look through and see, oh, here's two functions that do almost the same thing. Can I rewrite them so that I have only one function that performs both tasks? Or maybe I can redefine the tasks so that I can use the same function for both. And every time you can do that, you simplify the code base and you reduce the number of bugs in it, because D is large and complicated enough that when you change the way something works or add the way something works, you often will forget that you didn't catch all the places where the behavior has to be tweaked. But the more you get those behaviors to have or to share an implementation, the fewer places you have to remember to tweak for the behavior change. Yeah. So constantly on the lookout for things like that in the compiler. What functions can I eliminate by merging them into other functions that do something similar and that really should be the same routine? And in fact, the behaviors should match. And by doing that, you sometimes discover cases that you hadn't considered in one branch, but you had considered them in another branch. So by merging the routines, you eliminate a bug. By treating things that should behave the same way, they then actually behave the same way.
Okay, so Adam has some feedback. He says the problem with combining functions is then if they do legitimately diverge, you end up with one messy function instead of two clean functions.
Oh, well, that's true too. I find if I have a function that consists of too many conditionals in them, too many special cases, like you have path A through the function and path B through the function and even a path C through the function, and there's not a whole lot of overlap. Definitely split them into three functions, cleans up the code and makes it a lot easier to read. Yeah, that's kind of a judgment call. Or maybe split the function up into 2 or 3 functions, and the 2 or 3 functions only handle the differences, and then there's a main line which handles the common case. So, of course, it's always a judgment call of when it's time to merge behavior and when it's time to, split it up into multiple functions. And to me, that difference is when the function starts becoming difficult to understand because of all the if statements in it. Ideally, your function should be written with no control flow in it. Just a straight line A, then B, then C, then D, then E. And if you can rewrite your logic into simple control flow or the simplest possible control flow, you have much better chance of having a bug-free program. And that's why I like arranged programming so much. And with the universal function call syntax, you can have A.B.C.E, and that's how the control flow happens. I read a file, split it into lines, sort the lines, write the lines back out to a file. And that can be done in D and there's an example in the runtime library somewhere of making that work, sorting the lines in the file. And there's no control flow at the top end. It's all, A.B.C.E.F. And you can look at it and satisfy yourself, yes, that's a correct program. I learned long ago in the 80s that every if statement in your code is a bug. You can say that as in the language specification too. Every clause in the language that is a if this then that makes your language less than perfect. And every switch on your compiler is a bug because your compiler should be compile my code. That's conceptually what it does. And if you've done everything right, that's the only thing you have to say is compile my code. No switches, no options, no nothing.
So maybe you should make a separate compiler for each switch combination.
Well, oftentimes when people can't agree on the behavior, the answer, somebody always suggests, well, just add a switch to the compiler to change the behavior. And I really, really try to resist adding a switch to change the behavior, because having a switch, like an on-off switch on the compiler, instantly splits the language into two languages. And if you have two switches on the compiler, then you have four languages. And if you have three switches, you have eight languages. And you can rapidly see how this gets out of control and becomes impossible to test, because it's a combinatorial explosion. And how can you possibly even test all that stuff? And it becomes very confusing for the users, which switches or which options do I need to compile this and all that. So a good compiler design has no switches, and a good language design has no if clauses in the specification of how the language works. And of course, I've failed at both miserably. But I look at like the thousands of switches GCC has and go, well, at least we don't have thousands of switches.
Ricky, I hope you're still listening, because I'm going to go ahead and ask him the question. His question was, it starts off with Walter likes trains confirmed. What is your favorite type of steam locomotive? For me, it's Climax, a type of Shay.
Oh, I have to say, I guess I'm partial to the big boy.
The big boy, is that a specific train?
That is a specific locomotive, and it had a name and a model number, but it's the most gigantic steam locomotive ever built. And the people who are building it just nicknamed it the Big Boy. And the name stuck, and they kind of threw in the towel. It's like, D was originally named the Mars programming language, but everybody called it D, so I gave up and started calling it D. So the Big Boy, I like it because it's completely ridiculously large. And I remember reading about one of the last ones in existence. They were taking it to a museum, and it was, steaming its way on the tracks. And the locomotive was so long, it would force the tracks apart on the turns. So the train had to be followed by a railroad gang, putting the track back together after it passed. But that was built during World War II to haul coal and stuff over the mountain passes in the West. It was kind of the pinnacle of steam technology. And of course, I like all the steam locomotives. I like the little ones that they used on the logging tracks, the narrow gauge ones. They're just kind of neat. Simple but marvelous machines. Around in the Northwest, they just build these temporary tracks up up the sides of hills and then run these narrow gauge locomotives up to bring the logs down, and then they'd tear up the tracks and put them down someplace else. And a short ways away from where the house is, there's the remains of one of those roads cut across the side of a hill, and you have to know what you're looking for to see where it had been dug into the side of the hill. But it's kind of cool seeing that stuff. And every once in a while, you'll see a gigantic tree stump from the one of the original trees in the area, which they're all gone now.
Mm.
If I was an engineer 100 years ago, I'd be working on steam locomotives. And if I was an engineer, 60 or 70 years ago, I'd be working on piston aircraft because, I love piston engine airplanes. It's so cool.
It's the engineer in you. Well, I have a question from Adam in the live stream, but before I get to that, there's a question from Anonymous in the email. How many hats do you have?
I think I ran out, which is why I changed hats every 2 slides instead of every slide. So it's roughly about that. A couple of the hats were just too horrible to actually attempt to wear. So now, note that I never bought these hats for the purpose of having these hats. They all had one reason or another. I'm not a collector. I'm a hoarder.
So Adam, I guess the first comment might be connected to the question, so I'll read both. He says, with the scope success lowering, the try flag finally lowering works, but is liable to generate suboptimal code, adding exception handling stuff where it could have been injecting a nested function call at exits. So does the lowering make it harder to implement it well, since some of that high-level intention from the original code is now lost to the code gen?
Oh no, that the lowering of scope was, Andre's idea, because Andre's original proposal on this was for C++, and he did it with macros that rewrote it into C++'s constructs. And I was looking at that because sometimes it's hard to figure out how to implement the scope, the 3 different kinds of scope. And if I worked out how to do it with the try-catch finally, that's all I needed to know. All I needed to know with scope was, how is it expressed as try-catch finally? And then I could forget about scope. Yesterday, I complained about exception handling. Well, one of the reasons I complain about exception handling is in the implementation, it's a rich source of bugs. But the only thing I had to implement was try-catch and try finally, because the try catch finally statement is an amalgamation of those 2 constructs. So all I had to get right was try catch and try finally. And if I got those right, then I know that the scope constructs work. And that worked out really well for me, because implementing try catch and try finally, there's a lot of tricky logic in the back end and in the transformation to the AST to make that work right. And the implementation has changed over time because I found better ways to implement it, but I never had to go back and revisit the scope statement because it was literally rewritten in terms of try catch and try finally. So I never had to be concerned about that. If I got the try catch right and the try finally right, then I knew that the scope was going to work right. And so that has paid off for me quite a bit in code I didn't have to write, complexity I didn't have to deal with, bugs that never appeared. So the scope rewrites were really a big win.
Brian, his question is, you said one of the reasons for syntactic sugar was to help reduce bugs. What, in your opinion, was the sugar that reduced the greatest number of bugs? And bonus question, why was that?
Oh, easily the scope thing. Easily. Boy, did that reduce bugs. Like I said, implementing exception handling is complicated. It hurts my brain. And there's a lot of work to get it right. And by not having to implement it 4 times, once for the try catch finally, and then scope success and scope exit and scope failure, not having to implement it multiple times was just a huge win for me. So getting rid of bugs, that was the biggest win.
Ali has a question. Why is scope success seemingly more complicated than putting code right after body without using any try-catch block?
Because you can have go-tos out of your bodies, which exit the try body, and you need to have finalies hook into that too. That's the trouble with it, is there's more than one way to exit a code block. You can exit with a go to or break or continue statement. What the try catch and the try finally does, especially the try finally, is it intercepts all those exits from the block. By implementing try finally right, then the scope success is going to automatically work correctly. And those rewrites I showed in the slides, you'll actually find them as comments in the compiler because it's showing the rewrite of the scope statement into those. And that is literally what it does. It rewrites it into those form and then forgets about it. Also, a lot of the for each loops come in multiple variations, and they all get rewritten into simple for loops. And then, I only have to implement the for loop right, and I can forget about all the other loop constructs after that.
Steve has a question, and Ali and Steve both said it's a nice talk, by the way.
Thank you.
Even though the lowering helps the compiler avoid dealing with different types of the same construct, you want errors to be on your original code. How does the compiler deal with that?
That's a good question. Yeah, it first checks for the errors before doing the rewrite. Yeah, it hasn't really been a problem. I can't remember where it was a problem where it showed the error in the rewrite rather than the original code. Usually it checks for the ones specific to the before the rewrites. Yeah, like the scope guard stuff just checks for the errors before it does the rewrite.
You said this was a paradigm shift for you, looking at things this way. Has that colored the way you look at adding new features to the language now?
Oh, absolutely. In creating a new feature, if I can specify it in terms of a simpler feature, then I have much less documenting I have to do of it. So you see the same thing there. So most definitely it simplifies the specification.
How are you thinking of implementing pattern matching? Have you thought about that?
Yeah, that turns out to be not quite so easy to rewrite in terms of lower level stuff because there's some extra semantics on. And those extra semantics also make it more difficult to write as a library module. When you write something as a template in a library module, you are constrained to rewriting it in terms of the other capabilities of the language. When you want semantics that step beyond that, then you're going to have to write a custom thing in the compiler for it. An example of that is the D's associative arrays. It turns out that you can implement associative arrays in the library, but to get the exact same semantics as the one in the language, it turns out that you can't make that work with the library template because the way the associative arrays are done, it's not a simple rewrite.
Mm.
So I know Andre wasn't happy about that. It was one of his motivations for telling me that things ought to be done in terms of simpler language constructs so that they could potentially be implemented as a library routine rather than in the core language, which I think was a really great insight. But by then, the associative arrays had already been implemented and had been in use for years, and there was no going back on that. So, and he really tried to implement them.
Steve, he has something called the new AA he started work on.
I'm not recalling that.
Yeah, he hasn't. I guess he hasn't announced it. It's just
oh, okay.
This now. Looks interesting.
I don't remember a discussion like that.
A template library version of the AA implementation used by the D programming language.
Yeah, Andre would yell at me, "We can do associative arrays in C++ and they work fine. Why can't we do them in D?" And I go, well, because the associative arrays were defined before D had templates. That's why.
Why can't local variables be ref in D?
Okay, internally the compiler is allowed to do it. I did that as a simplification of the language for the user. I wanted to try it to see if we don't really need a ref for a local variable. And I think it's worked out. And it enabled me to make the semantics of ref special. Ref originally did not mean a reference cannot escape the stack frame. But since I had restricted ref to only being usable in function parameters, it turns out that I could repurpose ref to be a key component of memory safety by saying, if you pass a parameter by ref, the parameter cannot escape. If I'd allowed that on local variables and struct members and things like that, then I could not have done that with ref. By restricting what it could be used for, I enabled a new capability to be added to it without breaking any code. So that worked out pretty good. I keep thinking someday I'm going to be forced to allow ref on local variables and struct fields, but so far I've managed to avoid it.
Ricky has hashtag library implicitly nullable types win.
I'm not sure what.
When are we getting implicitly nullable types in the library?
Isn't that what sum types are? I mean, to me, one of the purposes of sum types was so you could have non-nullable pointers.
Void func nullable bang int, and you call it with func3. You give it a parameter of an integer constant
that may or may not contain a valid value. Well, I think sum types should work for that, shouldn't they? Because then you can create a sum type with an integer as one field and then a quote unquote pseudo null as the other field of the sum type, and then it's either the null value or it's an integer value, and you can make that work with sum types.
So no implicit casting to nullable.
Yeah, that's right. Then you have to use the pattern matching to test to see if it's the null value or not the null value. That's what the pattern matching part does.
Ricky expands. He says, basically implicit wrapping for constructors for function parameters. There's a lot of use cases. Okay, here we go. Walter, being a runner, I wonder what the best aha moment was when you went on a run in programming.
Oh, I've had so many of them. I can't think of one in particular, but I remember multiple times I had a problem that just seemed intractable to me. And when I was running, it would just suddenly occur to me what the solution was. It was like oh my God, Well, when I started running, my body never wanted to run, and it was always agony to get up and do it. But through a massive application of willpower, I kept at it. And after about a year, suddenly I realized that I was looking forward to going running and I enjoyed it, and it had become effortless. And it was then that instead of thinking about struggling through the run to finish it, my mind would start wandering when I was running. And that's when I discovered that it was really where I did all my best thinking, had my best ideas. It's where I write my presentations. It's where I solve the difficult problems. It's really where I do all my real work is when I'm out running.
I was laughing at Ali's answer to that question. He says, I can answer, C can import C.
That might have been one when I was running, because for so many years I thought, oh, that's impossible to do that. People would ask, why don't you just compile C? And I would go, oh, that's too much work. It's impossible. Well, not impossible, just completely impractical. And, one day, I don't remember when it was, I suddenly realized that I actually didn't have to implement a C compiler to make this work. All I had to implement was the C parser, because the D semantic routines are close enough that I can just, hijack them to do the semantic work on the C stuff. And that's not always. As Adam pointed out, some of the semantic routines have alternate paths through them for the C versions of the same construct. But once it gets past the semantic routines into the back end, it's all identical. It's all the same code. Well, I knew how to write a C parser, so it didn't take very long to write it. And there we had it.
When you're thinking those deep thoughts, solving those hard problems, does it ever distract you? I mean, not distract you, but blank you out from what you're doing? I mean,
oh yeah,
yeah. Where you're running along, suddenly you're meters ahead from where you were.
Oh yeah, I've suddenly realized I was a half mile further down the road.
Yeah, right. Yeah.
Which I found that if I try running through a trail in the woods, that doesn't work, because the trail is uneven enough that I can't get into the zone. I'm always watching for rocks and roots and the abrupt changes in altitude on that. It has to be on a level road with nothing I have to dodge. Of course, cars.
Yeah, I was about to say the same thing, because I don't run, but I walk. I walk a lot, and I often think when I walk. And when I'm in the city, I can lose myself in thoughts. But when I'm hiking on a mountain, I can't do that, because I can break a leg or something if I'm not careful. So
Yeah, I've never been able to get into the zone while driving, and I don't recommend anyone try because you can't zone out when you're driving. But, one of the things that concerns me is, one day I'm not gonna be able to run anymore, and then what's gonna happen to my programming? So
Mm.
I'm a little concerned about that.
Get
I
yourself.
I actually cut back my running because I was worried I was wearing out the joints in my knees and hips and things like that. And, like football players, their bodies are ruined by the time they retire and they live in pain the rest of their lives. And so, I'm not running marathons or anything like that. I kind of tried to figure out what is the most cost effective distance I can run. Okay, where I get the health benefits, I get the thinking benefits, but I'm not getting too much of the wearing out your body problems. And so I figured it was about, 2.5, 3 miles was the right distance for that.
Mm. Well, I have not run since I left the Army in 1994. So.
Oh, well, if you do run, just remember it'll take a year before you start enjoying it. That's a long time.
Ali has another question. Is at live still not working because you reduced running?
No, it's not working because well, actually, it does work. It just works on a subset of the language. But the reason I haven't been working on it is because, well, import C, and then there's this long list of other issues people want me to address. So, yeah, I find that a little frustrating because I think at live is going to solve or the last leg of our memory security issues. We've got pretty much everything else under control. It's just the ownership borrowing needs to be done, and then we've got it. We can proudly say D is a memory safe language without needing to use the garbage collector.
This is from Ali. Was there any hope of syntactic sugar for at live, or perhaps at live could be syntactic sugar for future features?
One of my goals of implementing at live was it does not add new semantics. It actually subtracts semantics. So it takes your existing code, it does not modify the way it behaves, it just puts a restriction on that code. So at live does not introduce any new semantics. What it does is removes semantics, like it removes the ability to create two copies of a mutable pointer. And if you think about it, all of the at safe, scope, and return annotations do the same thing. They don't add anything, they all remove something. So I think that is an interesting approach. I don't think anybody else does that, but I'm actually kind of pleased with it. It does that it only subtracts things. So it will not change the behavior of a working program. It just your program may not compile with it until you change it, but it will never change the behavior of a program that does work with it. Like you could take a program that works under at live and remove at live, and it will work exactly the same way. It just adds a layer of checking on top.
And while we're waiting to see if there's another question, Walter, you want to give us some parting thoughts?
I keep thinking of Robert's parting thought, which is D is the greatest language ever.
That's just going to become the default for everybody now. Yeah, want to say anything before you go?
Yeah.
D's the best language.
Yeah, I mean, I wanted to create the language I wanted to write programs in, and D's the language I want to write programs in. It was a big success as far as that goes. It's exactly what I want to write code in.
All right, I am about to pick the winner of the prize.